In these sample problems, we're looking at exponential functions. And the first thing we want to do is look at these four examples and see if the functions are linear or exponential. So notice that we add 1 to each one of these to get to the next number. So the difference is 1. On this one, the difference is 6. The difference is 24. And the difference is 96. Since these differences are not the same, this is an exponential function. On this problem, the difference is 1, 1, 1. The difference is 3, 3, 3. So this is a linear function. And remember, slope equals change in y over change in x. So it's a linear function with a slope of 3 over 1, or 3. In this example down here, the x is in the place of the exponent, so this would be an exponential equation. In this one, we have 12 times x. The exponent on the x would be 1. So since this is to the first power, we know that this is a linear function. Okay, they want us to graph the equation y equals 4 to the x, so we're going to pick values for x. So let's pick 2, 1, 0, -1, and -2. So since y equals 4 to the x, 4 to the second would be 4 times 4, which would be 16. 1 to the second would be 1. Sorry. 4 to the 1 would be 4. 4 to the 0 would be 1. 4 to the -1, remember that would be the same as 4 to the first, only we're going to flip it over. And 4 to the -2 would be the same as 4 squared, except that we will take the reciprocal of that also. And so now we want to graph these. So when x is -2, we get a 1/16, which would be right there. When x is -1, we get a 1/4, which is still about right there. When x is 0, we get 1. When x is 1, we get 4. And when x is 2, we go off of our grid way up here. So our graph is going to look something like this. Notice down here, it approaches 0, but it never reaches 0. It just gets smaller and smaller in a positive number. Okay, on this example, it's just like the one we just did, except that we have this negative sign. So we're going to use the same numbers, 2, 1, 0, -1, -2. So we would have a -4 squared, which would be the opposite of 4 times 4, so that would be a -16. A -4 to the first would be a -4. A -4 to the 0 would be a -1. A -4 to the -1 would be a -1 over 4. And a -4 to the -2 would be a -1 over 16. And now let's graph this. So when x is a -1, we get a -1/4. When x is a -2, we get a -1/16. When x is 0, we get a -1. When x is 1, we get a -4. And when x is 2, we get a -16, which would be way down here. And so if you look at the graph on the previous slide, it looks exactly the same, except that our negative graph goes this way, and on the previous graph, our positive one went this way. So they're exactly the same. We just flipped it over the x-axis, which is what your negative sign does. It rotates the graph over the x-axis. Okay, in this problem we want to solve x plus 3 equals 3x. And the easiest way to solve this is actually to graph it. And we're going to set up two graphs. We're going to make one y equals x plus 3, which would be a straight line. And our other graph would be y equals 3x. So we use each half of the equation to set up a graph. And so now when we graph y equals x plus 3, that tells us to start on 3. Our slope is a positive 1, so we'll go up 1 and over 1 for our slope. So here is the linear part of our graph. And then for y equals 3 to the x, we know that when x is 0, we'll have 3 to the 0, which will give us 1. When x is 1, we'll get 3. When x is 2, we would have 9. When x is a negative 1, we would have 1/3. When x is a negative 2, we would have 1/9. So here is our exponential part of the graph. So our solutions would be right here and right here where the graphs cross each other. And it would be easiest to graph this on your graphing calculator and then look at your table function to find these two values.